Appreciate it. Thank you. So I'm PaulCoggin. I'm out of Huntsville, Alabama. Work for a company called Dynetics, a historically aerospace primarily company, about 40 years. But we also do a lot of work in the commercial industries with automotive industry, and do a lot of work with telecommunications, utilities, service providers, enterprise, IT network consulting, and we also do a great deal in cybersecurity, hacking, and so my background, I've got about 18 years experience in networking, got a few degrees, got all the typical certs everybody expected to have today to work in the security industry. I do a lot of teaching, and I specialize pretty much in building or figuring out how to break into very large networks, very large complex networks, and doing vulnerability analysis, and doing the high-end routing and switching, like MPLS, BGP, all the routing protocols. This is a high-level diagram representing the next generation network architectures that are being implemented today for a lot of the telcos and utilities that are getting into smart grid. And at the same time, say if you're a utility, you're building out smart grid, you may be, if you're running fiber, since you're running fiber out to the home, possibly you may be also offering IPTV, voice, internet, et cetera, because you're running fiber out. Why not? You basically have the infrastructure to be a telco. And if you're a telephone company, to stay in business, you're running voice, video, and internet all the way out to the home. Basically, they're becoming cable companies. And of course, the cable companies are trying to do all the above as well. And that's basically what the architecture looks like at a real high level. And at the top, what we have is the network management services, or what we call the operation support services. That's your billing system. That's where your network management is. That's where your AAA radius servers are. That's where your, if you're a utility, your SCADA systems are going to be up there. Your internal billing system, your video head-in is going to be up here at the very top layer. And as you work your way down, you're going to have your core network infrastructure. If you're a very large telco, you're going to have probably a MPLS backbone where you're doing MPLS IP label switching. You may have a DWDM where you're multiplexing wavelengths of light across your fiber to make your fiber go further. And in addition to other higher end optical services across that core backbone, it could be that if you're a smaller provider, you're collapsing that core cloud down to the next tier, to what we typically call the distribution aggregation layer. It could be collapsed down. And then at that layer, you're aggregating up your access services, where you could be having DSLAMs, GPON, cellular network connections, where you're doing cellular backhaul for, say, like Verizon. All those different residential and business services would be aggregated up there at those lower layers. And the point I want you to get is what's happening is, if you don't get anything out of my talk, get this. When you're building networks or you're analyzing somebody else's network, you're building a brand new network and you want to get that thing secure, or you're analyzing the one that you already have, or if you're in a consulting facet like I am, and you're looking at other people's, don't get hung up on finding some day zero or finding some vulnerability immediately in Metasploit. Go and analyze all the different trust relationships, the interconnections, the interdependencies, all those, the integration. Because if you understand all that, you can go and find the weaknesses and vulnerabilities that are inherent through all those different trust relationships and interdependencies, and better secure the network, because the bad guy's not looking for one just little vulnerability. He's going to analyze things, and he's going to look at how everything works, and then he's going to find that one piece and start pulling on that thread. And so like in this case, you have online bill paying now, where everybody wants to be able to pay their bill online. You've got the smart grid, and where everything is going green, trying to get rid of the truck roll to the home so that basically somebody can pay their bill online over the internet. When they pay their bill, it connects to servers in the upper part here, in say the internal billing system. They turn around and talks to a provisioning system, and if it's a new service with auto provisioning end to end from the internet up to the network management all the way down to the business or home, new services can be automatically turned on, or services can be automatically disabled, if you didn't pay your bill or not. So it was building these type of networks. You've got to look at that whole chain of trust relationships from the internet all the way down end to end, and make sure everything is locked down tightly. An example of those trust relationships and interdependencies and interconnections here. This is an example of a transport network, kind of like that cloud we were looking at on the previous slide, in the middle of the slide there. This is like a transport network where you might have the high-end routers doing the MPLS routing, the DWDM where you're breaking out different frequencies of light to run across your fiber. So you might have one fiber with, say, 80 different lambdas, light frequencies being multiplexed across that fiber in the backbone there we're showing. And you could be doing cellular backhaul, et cetera. But one of the things that we always see from a trust relationship standpoint is you might have a vendor that goes and provides you the hardware for this one piece of the network, for this transport network. And that vendor is going to have a network management application for just their hardware. That network management application is called an element management system. Now that element management system may be tiered and managed by another network management system, say like HP OpenView or Netcool, but that piece of hardware there, that optical box, Sonnet, DWDM box, or say a high-end router, for example, or BSLAM, it's going to be managed by a vendor-specific software application to make it very easy to provision, troubleshoot, and manage those devices. And when they roll that into a network, one of the things they're going to want to do to make it so that you're very happy with your new network is they're going to want to have remote access from their network into your network. So that when you call and you have problems, instead of having to tell you step by step what to do, they're going to want to just come in and hand jam it out themselves, and just get you off the phone, and cut the email train loose, so that they can go and fix your problem very quickly. And so in that case, you've got to be very, very careful about locking down the remote management, both internal and external to that network. And in many cases, if the security guys are not involved with whoever, say, is running this part of the network project, that vendor may come in, and I've seen this happen in real world. What I'm going to talk about, I've seen happen in real world. The network management tech is going to want to get his project closed out, and they ain't going to call the security guys. Security guys are problems. Security guys get in the way of progress. They want to put in firewalls, put in access lists, limit who can talk to their boxes, et cetera. And so what these guys sometimes will do is they'll drop in a two-leg box, a multi-home, say, Unix box, with one leg to the inside and one leg out to the internet, bypassing the security guys' investment in firewalls, VPNs, IDSs, NetFlow, and all that. Totally bypass it. Poor network guy doesn't know what's happening because they just go and do what users do. They find an empty connection and they start plugging things in. You leave the room and they start patching in. Oh, I got a link light. I can ping. We're go. Ask me. This is real world. And then you find out that this happened to you when some bank over in Europe calls you and tells you to cease and desist, by way of a letter from an attorney, and you're like, what? You're looking at your logs. Ain't nobody, our stuff's cool. No, you start tracing it down. The CEO has a letter from a lawyer. You got to start scrambling. Then you find that somebody's put in that multi-home box and bypassed all your security. So you got to go and get heavily involved with these projects and make sure that those trust relationships are knocked down or locked down, so your network doesn't get knocked down. Now, when I have This is the process that I go through now, whether I'm looking at vulnerabilities and just doing vulnerability analysis or doing vulnerability analysis in preparation for a penetration test. And now if I'm trying to build a new network and doing design work up front for a customer, I make sure that myself and I'm teaching the network guys that work under me to look at the whole OSI model. Nobody wants to learn the OSI model and say, oh, that doesn't, nobody cares about the OSI model. You tell me you don't go and study the OSI model, and I'll tell you, I will hack your network. Never fails. Always get in. The guys who do not go and take the time to learn the 7 layers of the OSI model and learn the TCP/IP model and understand those different layers and what's happening at each layer and how the bad guys may be studying your network based on those different layers, there's a weak link somewhere. There's a trust relationship. There's an interdependency. There's an interconnection somewhere that all I've got to do is find one of those layers, and all the dominoes in the upper layers are going to fall. Layer 2, I wish somebody would secure layer 2. I wish somebody would do it. I've been in this business. I've been doing penetration testing probably since, I guess, 2003. And I have yet not to see somebody's network that you couldn't run a ARP poison attack against, for the love. They got everything patched, hard to guess passwords, passwords this long. You can't, there's no Metasploit buffer overflow. You can have Canvas, you got Core, you got all the tools, all the cool stuff. You got unlimited budget for tools, and you're running against the network. You ain't finding nothing. But if you can get local access in that network, you're going to find the layer 2 hacks, whether it's ARP poisoning or any of the switching protocols, the routing protocols. And I'll show you some of an example of a protocol running at layer 2. But everybody typically is worried about the higher layers, but you got to look at the whole OSI model. So when we're going to study networks, this is something that we also do when we're looking at laying out a new network or to build or to test under contract, under a legal authorized contract to do a penetration test, vulnerability analysis. We're going and study everything we can about the network architecture, based on the whole OSI model, what the routing protocols are, how's the transport network going to be built, who's providing all the equipment, the protocols that they're going to implement, or we're going to use open source, commercial, what can we understand about those. But we put a very deep focus on those trust relationships between all of the different applications and systems that have to communicate together. And based on what we derive there, we come up with an attack tree. And an attack tree is going to tell us, give us a really good idea is if we're building the network for somebody, how would an adversary approach our network possibly? And if we are the adversary under legal authorization, this is how we're going to go after the network and step through the network to possibly take it over. And my role on the penetration testing team for our company, I'm the router guy, I'm the network guy. We have guys that do applications, guys who do databases, guys who do operating systems. I'm the network guy. I want to go after the network devices. And everybody always asks me, so what? You get into my switch, you get into my router, so what? What can you do with that router? Well, things you can do with the router, you can inject new routes. If you can get into somebody's router, you can inject routes that their IDS and logging systems may not be looking for and expecting, totally foreign, unknown IP addresses. Say if you had a 172.16 base network, I could go in and hit you with, say, something out of the 5 or 6 octet network. And you would be thinking it's coming from some foreign network. No, it's actually on the inside. Your router's been owned, and we are injecting new routes into your network and working our way horizontal and vertically through the network. And you're looking on the outside, talking to your upstream telco, and they're telling you they're not seeing nothing from those IPs. They don't know what you're talking about. They're looking at their net flow. It's all on the inside. But your logs are looking at some foreign IP you didn't know about. It couldn't be inside. It couldn't be that you're hacked. Other thing is if you can get a hold of the router, you can put in route mounts. With route mounts, What you can do with route mounts, if you're not a router guy, is you can override the default global routing table that the routing protocols may have built with route maps. You can override that and develop an access list that defines the IP networks of interest to you and set a whole new policy that ignores the routing table and forces traffic to take a different path than it normally would. OSPF or EIGRP or your static routes may say to go this way. That route map will say for the traffic that you've specified of interest to go a totally different way and maybe bypass your security infrastructure, maybe bypass your logging, maybe point it toward a tunnel. Another thing, if you've got routers that's got the high-end code on it that have a very rich feature set, it could be that there could be a capability called lawful intercept in there. What lawful intercept is, you heard of the Patriot Act, CALEA, basically IP-based wiretap. What you can do with lawful intercept, that's what Cisco calls it. So when you see that, just think CALEA, Patriot Act. Basically what that does is just like in the old days, they used to tap your TDM voice line, your analog digital line. With lawful intercept, you can tap an IP connection. So I can go and use an SNMP version 3. There's some additional hooks depending on the train of code you have. You can define an access list with the IP networks that are of interest to you and configure the lawful intercept. So now, say criminal A and criminal B are having a conversation. Well, you turn this on, and now good guy C can get a copy of that whole conversation between A and B, and they never know that a perfect copy is being made. And that copy could be sent anywhere in the world. Anywhere you can get your traffic routed to, you can connect to. Well, that was the good purpose for it. That's what it was intended to do. But if you're a bad guy, and you know that this is in there, well, what if I just go and I don't wreak havoc on your network, and I just go and send a copy off of all the traffic that's interesting to me? Say your ERP system, your billing system, things like that. Other thing is, if you get into the switches, you might go and start doing port mirroring, et cetera, especially if you're on the inside of the network. But people say, well, what if I'm outside? Well, on the routers, there's a capability where span, if you're not familiar with it, is where you do port mirroring, where you can say mirror port 1 over to port 2, so you can get a full PCAP capture on a switch network. Well, there's a capability called ER span, where not only can you do that on a local LAN, but you can push that across your wide area network to another place in the world. So you can basically span across the cloud. That's something you could do. Also, get better recon out of the routing tables if you got the access. One of the things, I'll give you an example of an HSRP attack here in another slide or two. You can go and mess with the routing protocols. We've seen this a couple times in the last year, is using the router for a DHCP server. The network guy, he's got his DHCP server set up. Get a hold of the router, turn the router into a DHCP server, and use your system for the default gateway. Anybody that gets a new IP address, now they're going to use you for the default gateway. And you can set up a man-in-the-middle attack by that. So now, since you're the default gateway, anything that leaves the local LAN headed northbound across the router is going to go to the bad guy's system. Getting back to trust relationships, an emphasis on locking down all of those trust relationships from the outside all the way in, and very, very granular about locking things down. We had a network we went and tested. It was a black box test. Nobody knew anything except for the attorneys and the CIO. Very, very hush-hush. Nobody could know anything. Very, very large company. They had all the money. They had all the cool tools. They hired the engineers from the cool tool company on staff to run it, so they're not getting hacked. They had the firewall vendor, SE, they recruited, the IDS, logging companies, SE that they hired on staff to monitor this stuff, to make sure their network didn't end up on pastebin. But didn't work out well. So we came in. We had to go very quietly. We had to be very stealthy. Couldn't go and break any glass and make any noise and get ourselves blacklisted. So we went in and did the traditional recon. Found out a whole lot of things about the organization on LinkedIn, because everybody likes to brag and start working on their next job using their LinkedIn resume and bragging about how smart they are and all the applications that they've implemented on that current job's network. And we discovered that they have some web application issues that we were familiar with, and were able to get a shell prompt based on the recon we found on LinkedIn. We were able to go and get a very quick, very precise shell through a web application that they were running. And but the problem with that shell that we had is you could only it was only read-only access. You could do a little directory traversal, and being a one of the things that we found with that shell is we were on a Solaris box. And the younger guys that work for them, they all know Windows and they know Linux. Nobody knows Solaris anymore except for us old guys. I happen to be I used to be a Solaris guy in a previous life back in the mid-90s. And I knew a couple things about Solaris. One of the things I knew was about NIS being the directory service equivalent to Microsoft's Active Directory today. And I had them go and look, and we found that there was an NIS process running. And one of the things I've discovered, if I find a Sunbox running NIS, never fails. If the organization is running NIS, they have Microsoft Unix services running, and they have a trust relationship between that Solaris NIS service and their Microsoft Active Directory service. I always get a great big smile because I know what's fixing to happen. The dominoes are fixing to fall. It's going to be lots of PowerPoint, screenshots. We're going to have a great time. Somebody is not going to when we give the out brief. It's going to be ugly. Bring the Kleenex, Yeah. References for a couple of recruiters somebody might want to contact. And so what we found is we went and found that they were running NIS. And one of the things you can do with NIS, even if you only have read-only privilege, is you can run this command ypcat, and it will spit out the password file. It's read-only. You don't have root. You can't look at the shadow file. But if they're running NIS version 1 on some particular versions of Solaris, you hit that ypcat, it'll spit out the shadow file, hashes in the password file. So we got the hashes. Just so happens, trust relationships again. When we spit out that Solaris password file, it had all of their Active Directory username passwords in it as well. And so we had the keys of the kingdom. And now, granted, the Active Directory was on the inside of the firewall. They got a firewall, a big firewall, and they got a vendor, SE, that they recruited to work for them directly. So they're cool. They got a firewall, and they got IDSs and everything. But because of that trust relationship on the outside of that network between that Solaris system and that Active Directory, now we can totally own their system. Now, the CIO, we had to talk to these guys. Typically, we had to go and step our way all the way through. They always tell us, please don't crack passwords. They don't want you to go crack all the passwords because it causes IT chaos, if you start cracking passwords, especially for large organizations. So we stopped, like we typically do. It's very rare that people want you to go and, like I said, crack all their passwords for them. They surrender at that point, typically. But to finish, to see what all else we could find, to drive home again, the trust relationships. Who do you trust to connect to your network and specific services and different steps in different layers through your network? In this case, we found the firewall. And the firewall management interface could be managed from the internet. It trusted the world to connect to it. But they got a password on this thing, a hard password, a really good password. But because they had a trust relationship that was open to the world, and we had the passwords, we could connect in with that VPN client that you use to manage that firewall, and could manage their firewall. We didn't do it because we didn't break the passwords, but we could. Wanted to really bad, but we're an ethical company, and we don't do things like that. unless we're under legal authorized agreement to do that. Uh, we don't do things like that. So we could have ended up taking over the firewall as well. And the thing I want you to walk away with is trust relationships. That server that we were able to access, we would not have been able to do all these things. We might have found that firewall interface that was connected, we connected to the world, but we wouldn't have been able to do anything with it. We would have had to brute force it, and they probably would have found us and stopped us and put an ACL in place to stop us if we had only found that, I hope. But that NIS server running that web application, we should have never been able to see that thing because it was used for business-to-business applications. It wasn't business to the world. It was business to business. So they should have had that thing locked down, that server only have a trust relationship on the ports of services required to their partner. If they would have done the trust relationships, they would have had that locked down. Now, here's another example. I'm going to get into, it's not real technical. I'm going to go into it real deep because I'm sick of seeing it. I've been seeing this my whole career in security, and I want it to stop for the love. For the love. Let's stop this. Everywhere I see Oracle, it's a default install, and nobody puts a password on the database listener. If you go and scan it, it typically comes up as a low-level Cat 3 vulnerability. And then there's people that'll go and laugh, say, oh, Scott Tiger, you can connect to the database using TNS listener and log into the database, and so what, you got a database. Because in a lot of cases, you may get to the database, and it's an orphan database. Somebody went and fed a server a bunch of CDs, and one of the CDs was Oracle. I know because I'm a router guy, and I go and install all these apps. I used to in the old days before I knew security and I knew really what I was doing. Man, I need to go back and touch a lot of networks and clean them up. but the thing I've learned, if I don't know what I'm doing and why, I don't feed the CDs anymore. I don't install it until I totally understand what I'm doing to my system. But what'll happen is you'll go and install Oracle as a part of some kind of new enterprise application, and not go and get the thing locked down like it could be, in the example I'm going to give you, it could be for network management. And router guys like me, we don't let nobody touch our stuff. If it's going to manage our network, I'll take care. I'm a router guy. I know everything. So I'm a router guy. I ain't been to class on Oracle. I'm not a, I'm not a Linux kernel guru, but I know everything. Just ask me, I'm a router guy. I know how to program ACLs. I know IP addressing. I can do, complex IP subnetting. I know BGP. I'm a router guy. I can handle Oracle. And so can all my peers, I think. And so what you happen is you'll have like Oracle and you'll install it with network management applications. And in that system, you'll have your network locked down tight. I mean, you got access lists that are pages long. You can kill a toner on a printer, print out your router switch configs because all the access lists you have on it. That's cool. But you might not know Oracle and your Windows or Unix system that you put your network management application on as good as you think you do. And what we typically see, and it might be GIS, it could be any number of systems that'll have Oracle under it, but we're going to pick on network management. And what'll happen is and I'm going to show you, is you got your switches and routers locked down, but you didn't know, but you had Oracle underneath, and we're going to find that open listener, and instead of picking on Microsoft, you remember the old XP command shell where you could go and get a connection into Microsoft SQL Server and run the XP command shell stored procedure and drive commands just like you were logged in locally? Well, I kept on running into Oracle, and I was like, can't you do this with Oracle? Well, it turns out you can do it. It's a lot harder, but you can do it. And so we've gone in, our scenario here is we're going into a customer under legal authorized contract agreement. All the lawyers and the executives have signed off on it. Everything's above board. Asked us to go and test the network. We find a Oracle listener setting out on the server that has not been locked down securely, as it should have been. We put passwords on our Windows systems. We put passwords on our routers. Why not go and put passwords on the connections to the databases? And not just the login account, but the listener, the client server protocols as well. Now, so what you can do is if you find an open listener out there, like using your Nessus or EI Readiness scanner, there's a tool called OScanner that you can download. And you can point OScanner at that database, and it will go find all the default username passwords that are out there. Now, it's very rarely that I find a real database that's in use, what they call an Oracle instance. But whenever I do find an Oracle database that has a installed and they have a real legitimate application, there's always a default instance there. For the love, kill that default instance, get it out of there, because it's a security vulnerability. Because you may secure one instance, but what about that orphan default one? Somebody may come in and looking for that thing in an audit one day, or a bad guy could find it. And so we found, in this case, we found system, sys, others, and we found, the Oracle instance test database here that we're going to use for our talk here. So what if somebody sat through this talk, or one of the talks I do around the country about this, and they've actually passworded the listener? What can you do? Well, there's a tool called Oracle brute force, or brute, that will go in and brute force attack the database listener for Oracle, if you ever find one. And if you ever do, email me and let me know you found one, because I'd like to know somebody put a password on that listener, because I've never, ever, ever seen it done, ever. And I'd really like to know somebody's done it. And if they did it because of me, I'd like to have credit for that too. I'd like to know it. They influenced somebody for the good. So we've connected into the database here in the middle of the screen. We've logged in to system to test database, put in the password. We've logged in. Now we're at SQL. What are we going to do with SQL? We're not at a command shell. We're not at, with a dollar prompt. We're not at a C prompt. What are we going to do with this? So what we're going to do, turns out with Oracle, and unlike the old Microsoft SQL where you can just drop in and start doing XP command shell, with Oracle, we're going to have to do a few things. First thing we're going to do is we're going to have to give ourselves read, write, execute permissions. So that's what we're doing here. We're running some SQL commands to grant ourselves permission. And after we give ourselves read, write, execute permission, we're going to write a short Java stored procedure that is going to allow us to run command shell commands, just like we're logged into the local box as a MCSE. And so in the top, we have developed our little script. The first 12 lines is a little bit of Java stored procedure code. In the middle of the screen, we are compiling that code so that it will run. And then the lower quarter of the screen, what we're doing is we're using SQL, SQLnet, and we're executing our Java command procedure that we developed, and we're feeding it cmd.exe, and we're doing a dir to make sure it works. And we get a directory listing. The thing that's aggravating with the Oracle attack, I'm not an Oracle guru. Somebody that's really good at SQL can probably show me how to polish up this attack vector. The thing I found so far is you run that, you got to feed the output to a text file. And so we're feeding that directory listing to a text file, but it works. It runs, it runs successfully. And so we're good. So we got a command shell through it run by running SQL. What are we going to do with it? Well, we're going to add ourselves a user. We're going for root. And so we're going to go and use the command, the CMD executable to run Windows commands. And one of the key things here is when you install Windows on when you install Oracle on a Windows system, it's going to get system privileges. So you're basically root, guide, admin level. You got the keys to the kingdom through that process. So now, by way of Windows trusting Oracle, and having that open trust for the Oracle SQLnet protocol, the TNS listener service, we're going to start adding users. So we add the user hacker, and then in the next line I got circled in red there, we're going to add the user hacker to the administrator group using the net commands, feeding that through the Windows command shell through SQL, through SQL commands. And so now we've added a user to the network. And from there, we could go on and spread influence across the network as a Microsoft admin. But that's not cool. We want to go do more. We really want to go and show what you could do through SQL about having access and being able to pivot just through SQL. Do something interesting. Yeah.
Is that okay? Couldn't you just recreate the default user to not allow those permissions? And would and
No.
entirely you permission yourself away from having.
But what you should do is, one, you should password that service so that nobody can go and just openly connect to your database and enumerate.
In the first place.
What's that? Oh,
User should not have those permissions in the first place once the application calls for it.
okay. The account we found was system.
Yeah.
In the database, that's like DBA. That's like, an MCSE administrator account. You should, a couple of things here. One, there should never have been a trust relationship to the network that anybody could connect to the Oracle TNS listener service. I think it's on TCP port 1521. If I connected that, I should be prompted for a password. My client-server application should have a very hard-to-guess password, say like your ODBC drivers, et cetera, that you're connected with. They should have a very deep password. And then you should have all the passwords changed on all the default accounts, disable the default accounts, only have your own obscure accounts set up with very complex passwords. You got to have tiers of security. So yes, that's right. But before that, you should also have that service locked down.
I have a question. The local box, compromising the local box is
Yeah.
bad, but that doesn't make you an enterprise. You just got in, you got into the kingdom, but you're not king of the kingdom.
But if there's a trust relationship between that box and another box.
Now, if I'm on that network, this is real world. I didn't hack your network, everybody else's network. If I get admin access, I have never not been able to traverse horizontal and vertical through the whole network. Because something us network guys do is we use the same passwords everywhere. It's the admin on Windows, the root on Unix, the account on your routers and switches that never get changed. It's the same. And even if you did change them other places, I got admin access on this box. I'm going to upload tools and I'm going to get your passwords too.
What if you disable passwords and just go on with straight SSH keys?
You might have something there. Nobody does. I haven't seen
That's
that.
what I do.
Really?
Yeah, I don't
Okay.
deal with passwords. If it's not encrypted key, forget it.
Right, yeah, and even really secure ID, two-factor authentication is where,
Moving towards that, I'm not there yet.
yeah, if you want to stop APT and stuff like that, you need to go to two-factor. Passwords are garbage. Passwords do not work. If I can malware you, if I can get you to open it, it's over with. Passwords are useless.
I'm not an Oracle person at all, so think that this is a primitive question.
Okay, no, I'm not either.
Is this some kind of 16-year-old unpatched version of Oracle, or is this a normal secured install of Oracle?
Oracle used all their money with that were allowing security to sue Google.
So, here's what I found with, I'm not an Oracle guy. I'm a router guy. I know routers and I know how to break into networks. I know how to build networks, secure networks, and break into network infrastructure. I just kept finding this, and it was annoying the daylights out of me because we'd write the reports. It would have this vulnerability, and there was always this so what factor, and it was driving me crazy. We kept finding this thing. What can you do with it?
This also completely dodges the point that if an application is sitting on top of this, you've completely owned that application.
Oh,
And
yeah.
what is that application tying to other applications?
Right.
And there's typically an API connection.
That's right. It's all about those trust relationships, that whole, the OSI model, moving your way up.
Even within A, or the A level, application level, I would say you need to expand that further out and then
Absolutely.
look at all the API connections.
Absolutely. Yeah, I'm with you. I agree.
So this is just basically, what I'm asking, this is just how Oracle works.
Well, there's a more generic pattern here also.
Okay, got it.
Yeah. And anywhere I've gone, if somebody lets Oracle in the building, they install the CDs, they don't lock this down. Somebody might do it. Some people in this room, 2,600, they probably lock it down.
I was just gonna say the same thing, MySQL does the same thing with root and no password, and that's the default install. A lot of people don't add a new account, they want to fix that. The other thing is, to your point, was that there's replaying attacks, and so even if they use secure passwords everywhere, just replay the hash.
Yeah, pass the hash. Yeah. It's two-factor.
Unless they're using interpreters.
Yeah. And so to further drive home the point about the trust relationships and and lock down everything and look at that whole kill chain of who trusts who, what works together, what is integrated together to work, whether like that is it, tiers of applications, and those applications working with a piece of middleware, that middleware working with a database, that database laying on some Unix operating system or Windows operating system, all the way to the network devices. What does that kill chain possibly look like? And in this case, just for the example to help drive the point further home, we talked about at the beginning of this presentation, or many slides ago, that the router's locked down hard. If you print out the router config, it's going to kill the printer cartridge. You have to change out the toner. It's going to be the ACLs are so long. But if you get access to this box, because the router trusts this box, because it's running a network management application to run SNMP tribes, to do cricket, MRTG monitoring, bandwidth performance monitoring. Because it trusts this box now, we can use this system to attack our network infrastructure. And ask me, I do this. I may not do it through Oracle, but this is what I'm going for. I'm a router. I go after the network infrastructure, but I'll hack your Windows system and I'll do a web application hack if I have to, just to get where I can go and exploit this trust relationship to get the network. And in this case, we're going to do that, and we're on this Windows box, and they don't have the tools I need to run through the SQL command we've built. So what we're going to do is we're going to use TFTP to upload snmpwalk.exe. If you've been through the EC Council CEH class, they got all the tons and tons of tools. And whenever I teach those classes, everybody's like, what are these old commands? They don't matter. Oh yeah, they matter. You might not understand unless you take my class. You take my class, you will understand and appreciate it, because I go old school. Because your customers in the network, your next job is going to be old school, and they got old school budget, and all that stuff still works. And so we're going to go and upload snmpwalk.exe that we download off the web, and we run TFTP pointed toward the IP address of the router, get that uploaded using TFTP, and now we're going to use our Java command shell that we developed for the Java store procedure, run that through our SQL prompt that we have, run snmpwalk, and in this case, we're picking on Cisco just because this is no vulnerability, no day zero. Hopefully nobody will sue me for going and showing this. Other people have talked about this vulnerability. But this happens across the industry, and we just it's like Groundhog Day. You keep seeing these kind of problems over and over. So it's very valid. And another thing about us router guys, we get something installed. The Windows guys get clubbed about the head and shoulders about doing, patches, continuous patching, Adobe patches. Us router guys, we don't ever touch our stuff. We don't. We get the stuff in, and we sit back and we laugh at the Windows guy. It's the reason I don't want to do Microsoft, man. No, man, I'm a network guy. I'm in the cloud. I don't worry about Patch Monday, Patch Tuesday. The latest day zero for Adobe. Not my problem. I'm a router guy. Routers don't run Adobe. But the problem is though is culturally, us router and switch guys, we gotten too comfortable, and we don't patch that stuff. And you go into networks, and there's things like this, low hanging fruit, running under the radar. And that Microsoft guy, he's being beat up and abused, threatened with his job and everything else. So he's got everything locked down. He might be doing the two-factor authentication.
I knew a business owner at one time who had a bad experience at one time with Microsoft. Hacked it, infected it, broke the system. His policy now is he didn't want to patch anything. He'd rather keep he'd rather keep the existing vulnerability than take the risk of patching something.
Right. And so this so happens with some of the routers running these trains of code here. If you know the SNMP read-only community string, and read-only is a non-privileged SNMP community string. There's read-only and there's read-write. Read-write is like admin level using the SNMP protocol. Read-only, you can read, you can enumerate, you can get some information, but you can't get the privileged information like download and upload new configs. But if you were to go and SNMP walk these devices running that version of code, and you could guess the read-only community string, when you do an SNMP walk and you walk the SNMP MIB and step through the MIBs, when you hit the right point in the SNMP MIB, it will cough up the read-write community string and tell you what the admin root equivalent password is for SNMP, where you can turn around and own the network devices. And that's what we're going to do now. So we're going to run this command through our Java stored procedure, through SQL, SNMP walk the router, the IP address 192.168.1.2, and we know that ISO dot number there, that is the specific point in the MIB that we want to walk. And we fed that to a text file, SNMP log1.txt here. And here's the output. And you see right on the right here, we're doing the SNMP walk, and we're throwing the public community string at the device. And we get down toward the middle, and we find that the read-write privilege community string is company RW. In this case, company RW2. Here's the thing. With these routers and switches, you have to go out of your way and do this. This is not default. There's some network devices, like a Solaris. You go and do an SNMP walk against the network. Solaris is going to have public, read-only, pre-configured out of the box. With Cisco, and you're right, and say like Juniper, as far as I remember, you got to go out of your way. You got to go put that in there. But people go in and put in public, like they do Cisco in San Fran, because they took it in a class. They took a router class, and they got home when they opened the lab book to program their routers, and they did what they did in class. Type it in, and they type in the passwords. You and everybody else. And so a lot of times you can get in with something just as cheesy as public. But if you don't, you can go and run a password file against it, just like you would a dictionary attack. You could automate and run a list of dictionary words against the network devices, just like you would passwords, say an SSH brute force attack. You could do it against SNMP as well. And because we've found this level of password, we can now, through SNMP, upload and download the configs, get the router passwords, modify the access list, open up the trust relationship, put in new access list, leave their huge, long, humongous ACLs, and inject our own custom ACL that'll be hidden in the noise that permits us to go in and manage the network and spread influence horizontally and vertically through the network. Now, another example along the lines of Oracle. This is amazing. For the love. I mean, first hop redundancy routing protocols. You're going to do all the right things. You want redundancy. You got two routers for your default route instead of having one router for a default gateway off the local LAN. You go and you put two routers in side by side, and so that that'll work dynamically, you set up a first hop redundancy protocol between the devices. If you're a non-Cisco shop, you would run VRRP. If you're an old Cisco guy like me, you're going to run HSRP because that's what you learned 100 years ago when you first got into networking back in the early 90s like me. Though the Cisco would do the VRRP as well, just like the Juniper and the Extreme and Founder, et cetera. But what amazes me, it just blows my mind. I just don't get it. Here's your options. You do clear text. You do clear text authentication or MD5. MD5 hash with password. If you're going to go through the trouble of putting a password on that protocol, if you get it, I need a password because I don't trust my users. For the love, use the MD5. Yes, why not use the MD5? But nobody does. It's better. It's better than that. I mean, geez. I mean, at least make it hard for the MCSE, on staff, to break into your router. No. But at least it ain't clear text.
It's a false sense of security.
Well, at least it ain't clear text, though. It's better. I mean, you got to work with me here. No, but I mean, it's better than the clear. I mean, because what'll happen is probably whatever they use for this, they also probably in a lot of cases used for the SNMP as well. You know, for consistency. You know, Lord forbid you have to remember more than one thing.
Is it possible to patch that third party and put a different authentication or encryption method in there, or you're basically stuck with those options?
You're stuck with that, but what you do is you go in tiers of security, you know, the trust relationships, and you put in some security on your network to not allow other devices to run the protocol that you're running as well.
Run that strictly through its own tunnel that is encrypted.
No, because it's multicasting that on the wire. It's multicasting that on the wire because here's what happens: is the two routers are doing a heartbeat between each other. And as you see here, we got 192.168.1.1, and we got 1.2 are our routers, and they're advertising down at the bottom virtual IP address 192.168.1.3. 1.3 is what's going to be put in. It's what you're going to put in your DHCP server to hand out to your clients, or you're going to statically configure your clients to use 1.3, and so that'll be in the ARP table. And everybody's going to point to 1.3 in this case, and it's got to be in that VLAN so everybody can see it. Now, what you could do, though, is you could lock down the network, your VLANs, doing, say, like VLAN ACLs, et cetera. You could go lock it down so that nobody's going to do HSRP with you, in addition to having a good password. And log the crap out of it, you know, like Kiwi or something, you know, and flag it if somebody else comes on the network. Like if it's to show you here, is we can take that Wireshark PCAP. If you're in Linux, you could use Ettercap, Scapy. Yeah, you know, the guys I work with like to use Scapy because they like, you know, they're Python guys. If you're a Windows guy, just to show you how easy it is, you could download Colosoft. It's a Chinese tool, and you can go in. It's a really good tool. You can go and import your Wireshark and point and click, no scripting, just point and click and say the line 1.1 there, and you can go and edit any of the fields in the whole packet, just point and click very easily. And in this case, say I came on the wire with 1.50 there, and I'm going to edit, say, the 1.1 IP packet there that just keeps on continuously getting put out on the wire. And then I'm also going to change one of those packets so that the IP address is 50 for my IP, and I'm going to modify the opcode to 1. So because I want to preempt and take over this HSRP conversation that's happening. And you see over on the right there, the 1.2 has a priority of 110, and 1.1 has a priority of 100. So in this case, 1.2 would have been the primary router responding to any traffic leaving the network for that 1.3 virtual IP address there. So I'm going to bump up my priority to the highest priority of 255, and I'm going to take over. And now I went and edited these packets. The problem is I went and I've modified this packet and I've edited it. And so what you have to do now is you have to go up there and create a new checksum so that the packet will be recognized as a good packet on the wire. Do a checksum, and then you can go click on send, and you can go and replay this on the wire with that heartbeat and take over the network. And then what you could do, what will happen is if my computer that is running on the 192.168.1.50 IP address, if I'm not set up to do IP forwarding, well, I just caused a denial of service attack. If I'm set up to do IP forwarding, any traffic leaving the LAN, headed northbound out the router, is going to come to my computer, and then I will forward it on. I'm not going to get the traffic that's headed back south, say from the cloud, back to me, but anything leaving the network, I'm going to capture a copy of. And you can do the same thing with VRRP and some of the other protocols. Excuse me. One of the big recommendations I have is to get some instrumentation on the network. Get some visualization and instrumentation on the network. Know what's happening on your network. Baseline that network. Know what normal is. What is normal? How do I know I've been hacked? How do I know it's just not some computer is misconfigured? Right. Right. Or, if you want to detect APT, APT is all in the news, the Chinese, cyber Armageddon. If you want to know what normal is, but get some tools on the network and get it baseline. A really, really good book to get if you're into open source and you don't want to go and spend a lot of money on commercial tools. There's a new book out, Network Forensics. They go into really, really good detail in that Network Forensics book on a number of open source tools that'll help you get visualization on the network for like NetFlow, PCAP, and so you can baseline the network and figure out what is normal so that when somebody hits that link or opens that piece of malware up, some hot PDF, and ET starts phoning home, well, you'll know about it. They start doing exfil at 2 in the morning. Well, if you've got this capability, you'll know, hey, we don't have traffic leaving our network at 2 in the morning. Again, to go back to, and I tell you, one of the things that should be happening here when you do this baselining is you should have a really good baseline of your trust relationships and the integration and the interconnection between the different devices and servers on the network, so that if anything starts painting on the graphs, it's abnormal. If devices like flow, you get NetFlow going or SFlow, so that, why is my printer talking to Southeast Asia? One, why is your firewall and your routers permitting your servers on the internal network or your printers on the internal network or copiers to talk outside of the network? I mean, really gets back to trust relationship. Why would a printer talk to anything other than the print server? But if you got things locked down and you got good baseline historical graphing, you could catch something like that. Here's an example of I got 2 stories here with this chart. Customer who put in a great deal of visualization on their network, a telco service provider. They put in a lot of instrumentation on the network, logging anything happened, anybody logged into the network, anything abnormal, they were graphing it and monitoring it, and they had it all baseline, and they could tell when any nonsense was happening. A second customer, they didn't have anything. They knew better. They could hold the fiber in the rack, and they could tell. They were a supreme ninja. If you didn't believe it, just ask them. They were a deity network guy. Until somebody decided to write a script targeting DSL routers on their networks. And I don't know who else's networks got targeted, but I know 2 that did, personally. And the one that put the instrumentation on, when that script got fired up, started targeting all the DSL routers and exploiting the open trust relationship that those DSL routers had, so that anybody from the internet could connect to those routers. They were using a backdoor username password, and then going and reconfiguring those routers to use some bad DNS, so that when the home users did DHCP, they got bad DNS, and then they'd go off to the wrong sites and get their connections hacked. The guys with the visualization on the network, they were able to catch it very quickly what was happening. Now, what they should have done, they should have went a step further and locked down and only permitted trusted IP addresses on their internal network from their technicians to be able to connect to those DSL routers for remote troubleshooting and remote monitoring, instead of trusting the whole world. But they at least had part of it right. The other guys, they didn't have no visualization and they didn't have the trust. There's no telling what else is hacked. They just haven't found out about yet. It's the letter you don't get you got to worry about. So that's one example, again, of the trust relationships and adding the visualization. Again, putting visualization on the network, whether it's open source or the commercial tools, I'm really big on having the ability to get large amounts of PCAP and long-term NetFlow storage. Storage is cheap now. Hard drives are cheap. I want baselines forever. I want to know what's normal and abnormal, and be able, when needed, looking at historical flow data and performance data, be able to go in and grab full PCAP when needed to troubleshoot problems. In this case, had a customer, they put all the right tools in place, had a training issue, guy wasn't trying to be mischievous, just trying to do his job. Thank goodness they had the tools on the network to troubleshoot. They had a transport network set up so that to run triple play, what we call voice, video, and internet. Triple play services, one phone bill. That's the big selling point, one phone bill. Get your cable, internet, voice, one place. Well, they had a network built out for that, and this particular vendor for the video network, for the multicast video network, they had it ingrained in the chipset of the hardware so that the IGMP multicast traffic, anything that got put into the video VLAN, it in hardware ASICs was multicast across the network. It did not wait for the normal IGMP process to happen. It immediately did it in ASIC, basically broke the RFCs, but they wanted it the network optimized so that video, so that when you sit at home clicking your remote control, changing channels, going between channels, and what the customer didn't know is that when they change channels, they're changing IP multicast groups. So they want that to be really, really fast. So what this technician did is they accidentally provisioned a large group, a ring of internet traffic over into this video network. And this was before cable TV was even put on the network. It was just out there, ready to be used. They're using it now. Lord forbid they do make that mistake again now, that they're in the cable TV over IP business. But when he put that internet traffic over into that video VLAN and the hardware ASICs were doing IGMP in the ASICs automatically, you can imagine what a bunch of internet users, like in the thousands, do. They're out there doing ICMP ping, denial of service, the old malware type stuff, doing DOSes against Microsoft and whoever else everybody's against today. They dropped that over that network, all of a sudden that denial of service against Microsoft, it was attacking the whole network and, say, Microsoft and whoever else it was targeting. And what we were able to figure out, because they had the instrumentation on the network, we were able to understand what was happening. Because that hardware was doing that multicast automatically, we started looking at the PCAP, the Wireshark captures. We were seeing ICMP ping traffic encapsulated in multicast IGP. You don't multicast ping. Ping is unicast, me to you. But this stuff was being encapsulated again in another layer 2 packet, shot out across the wire. That gets back to that OSI model. Because I saw that, I was like, what in the world? And I had to go back old school OSI model, like this is how stuff works. What in the world is ICMP ping in huge amounts doing an IGMP multicast? Like, oh, we put this thing over into the wrong VLAN. And it took out a transport network, the whole backbone for a large service provider. But if they did not have the visualization, instrumentation, and baselining to troubleshoot that, we'd still be there every day trying to figure out what happened. That's what I have. Any questions? Yeah. So the question is, assuming that your network is compromised, how do you start looking at it? And here's my advice: your network's compromised. Here's the facts. There's the people who know they're hacked. There's the people that think they may be hacked, and then there's people who are in total denial and ignorant of the threat. If you have anything of value, if you're a business and you have anything of value, somebody's trying to get in, and they're sending you and your users stuff all the time. I get hit. I get people sending me junk constantly, trying to get me to open PDFs and things like that. They're targeting people. If you got anything of value, they're going after you. And the guys who would know from the large manufacturers and software application companies, I go all over the country to these conferences, and the guys who would absolutely know, they're saying, you're busted. Just deal with it and come out and work it. So the way we're going to work with it is what I'd recommend. You got to get instrumentation on the network to know and baseline what is happening in those different VLANs and those IP subnets, and log that and look at those trust relationships. You know, printers and copiers are not going to the internet. They're only talking to the print server. The print server's not going to the internet. My VMs and servers are not going to the internet. If it's not DMZ-based services, you know, your public services, why would they be talking to the internet? Stop it. And then baseline your traffic using open source or commercial monitoring logging tools, and be able to figure out what's happening. The only way to figure out what's in and how bad it is to get instrumentation on that network and baseline it and see what's happening. Because if somebody gets in, they didn't just hit you with one thing, they hit you with lots of things. When we go in and do a pen test, we will go in and set ourselves, if it's in the contract, we will go and set ourselves up with lots of different capabilities and access. So you shut down one, well, we've got another one. You shut down this one, well, we've got another one. So you've got to get that traffic baseline where you can know what's happening. And don't ever assume that they just got one box. That's where the big problems are, especially chasing the malware that's getting inside these networks, is they're assuming that they got one box. No. I'm a redneck. I get one box, I'm moving horizontal, vertical, diagonal, all through your network. If somebody's really good and they're mischievous and they ain't got nothing but time and they're motivated to go after your network to begin with, they're all over the place. And they didn't have to go call the lawyers and sign lots of paperwork and swear they'd never talk about you in your business ever again, you know. They don't have to go through all that paperwork like I do. They don't have rules of engagement. That's what we had to do. We had to do rules of engagement. You will only go up to this point. No, they got your passwords. They got everything. So you got to get that network baseline with your traffic to see what is normal. Because if you got users on your network, they're going to open the email. They're going to. And they're going to hit that website. And even if they've been trained and they don't open the email, they surf the net, legitimate websites are getting popped. The legitimate websites are getting popped, so you hit that. I mean, I could hit it and get popped. And I'm looking, I'm paranoid, because they really are out to get me. I'm convinced. We're at war, in my mind. I'm very scared. And I want lots of logging. So get your network baseline, get some visualization on it. Like I said, a good book to read is the new network forensics book that's out. They go into a lot of detail in putting network forensics capabilities in place, using open source tools so you don't have to go spend a lot of money. There's a lot of good commercial stuff out there. But get your network baseline. Another really good piece of advice I can give you, because we see this everywhere on the networks, is there's a Cisco Press book called Land Switch Security, What Hackers Know About Your Network That You Don't. Money you can spend. Because if you got a network and you got switch protocols, you got layer 2 protocols running on that network, if somebody wants to wreak havoc on your network, they could take that book and start wearing you out. They go into a great deal of tools about a tool called Yersinia that makes it really easy to go and attack all these layer 2 protocols. And the other book to help answer your question, if you're assuming that your network's been popped and you want to go in and get some visualization on it, another really good book is a book called The Tao of Network Security Monitoring. You get the Tao of Network Security Monitoring, get the book Network Forensics, and don't do like what everybody else does. All in this room, we all read. Our peers, they get a really cool book and they put it on the bookshelf and they don't read it until the boss threatens to take their job, because somebody's, come in with with the cease and desist letter, and then all of a sudden they put it on their desk. I'm on it, boss. Any more questions? Cool. I appreciate you guys letting me speak to you today. Hope you got something out of it.
We'll go ahead and take about a 10-minute break before the next presentation, so 10 minutes.